Okay guys, welcome back to the next episode on solving June 2023 for the maths paper 1. So let's continue with question 41. The coefficient of restitution E of two colliding objects satisfies which inequality? So the coefficient of restitution is actually it has different values. Now generally it is between 0 and 1, where 0 and 1 are included. Alright, so the option is A. Now in a case where it is equal to 1, the collision is said to be perfectly elastic. In a case where it is equal to 0, the collision is said to be perfectly inelastic. In a case where it is between 0 and 1 strictly without including 0 and 1, then the collision is just said to be inelastic. So since I have not specified if the collision is elastic, inelastic, perfectly elastic or perfectly inelastic, then we need to take all the conditions. So between 0 and 1, where 0 and 1 are included. So 41 is A. 42. Where is 42? Alright, the value of K for which this is a probability density function is, so for it to be called a probability density function, then the variable involved is supposed to be a continuous random variable, because only continuous random variables have probability density functions. Discrete random variables have probability mass functions. Alright, and continuous because you see the interval x is from 0 to 4. If it was a discrete random variable, then x will be equal to, x will have values 1, 2, 3, 4, but here x is all over the interval 0 to 4. So by definition, because it is a probability density function, then the integral of the probabilities is equal to 1. Alright, so I'm going to integrate from 0 to 4 of the probability function, plus I'm going to integrate from, in fact, if we consider any other value of x, the probability function is 0, so we just ignore this portion down. So all we need to do is integrate from 0 to 4 of this function here, and we equate to 1. Okay, so all I need to do is the integral from 0 to 4 of k times x plus 2, the x equal to 1. So this means that, let's just integrate normally, keep k outside, integrate x, we have x squared over 2, integrate 2, we have 2x. It is from 0 to 4, then we equate to 1. So if you fit 0, which is a lower bound, the result will give you 0, so just fit 1. So just fit 4. 4 squared is 16. 16 divided by 2 is 8. 2 times 4 is 8. So you realize that k will be equal to 1. 1 divided by 16. That's the value of k. So 42, 1 on 16. Option B is correct. Oh, sorry. Option B. Now let's go to 43. So please, if I made any mistake, try to indicate in the comment section. Alright, because I might have made a mistake, and I don't want to verify. I want you to verify if there is any mistake with the integration process or whatsoever. 43. A liquid is filling a container at a rate of 2 over x liters per second, where x is the quantity in liters of the liquid in the container at time t seconds. 10 liters are initially found in the container. How many liters will be found in the container after 75 seconds? So we have to create a relationship between the rate of filling the container and the quantity in liters at time t seconds. A liquid is filling the container at the rate of 2 over x liters per second. So it means that the rate of filling, which is dx by dt, right, is equal to 2 divided by x. Now there will be no negative sign here because you are filling. It's kind of a growth, right? If the container was leaking, then we are going to indicate a negative sign because there's there is like a decrease in something. So since there's an increase in the amount, then we have this. Alright, so we have this a first order differential equation where we just have to separate variables and integrate. So I have x dx equal to 2 dt. Alright, now we are going to integrate both sides. So when I integrate the left hand side, integral of x dx equal to 2 times the integral of dt. Now I'll just integrate and add the constant of integration to one side. So I have here x squared divided by 2 equal to 2t plus the constant of integration k. So which means that my x squared will be equal to 4t plus 2k. 4t plus 2k. Now we need to find the value of k, that is the constant of integration. To do that, we need to use the initial conditions. 10 liters are initially found in the container, which means that at time t equal to 0, x is equal to 10. So you realize that 10 squared, I'm replacing x with 10, will be equal to 4 times 0 plus 2k. Alright, so from there, what is 10 squared? 100 equal to 2k, which means that k is equal to 50. So it therefore means that the quantity of water available, x squared, will be equal to 4t plus, in fact 2k is equal to 100. So we just needed to find 2k, because if k is 50, we replace back here, we still have 100 plus 100. So this is a relationship between here is t. Here's a relationship between the amount of water present and the time to fill the container. Okay, now the main question is how many liters will be found after 75 seconds. So take t to be 75. When t is equal to 75 seconds, x squared will be equal to 4 times 75 plus 100. Now 75 times 2 I think is 150, so times 4 will give us 300. 300 plus 100 is 400. Alright, it's 400. So we just take the positive square root, because liters cannot be negative. So we have the square root of 400 in liters, and the square root of 400 will give us 200 liters. So option 40, question 43, 200 liters. Is 20. The square root of 400 is the same as the square root of 100 times the square root of 4, and the square root of 100 is 10, the square root of 4 is 2, so 20 liters. Option C. Okay, let's move on to 44. Given that dy by dx is equal to x minus y and y is equal to 1 when x is 0, the value of y when x is 0.1 using the sibling of 0.1 and the approximation this is, I think we have seen this before, right? we need to find the value of y when x is now 0.1. You realize that moving from 0 to 0.1, we have just added a step length. So we need to find the value of y when we need to find the value of y1, because we have x1, we have y0, we have x0. So same story as we had previous, and I think it's the same approximation. Yeah, same approximation. So I'll just have to go and copy what I have here. Alright, so I'll just basically copy what I have here. Alright, so but according to this question here is minus, but the same approximation, the same step length of 0.1, but there's a minus sign here. But now we have that x0 is 0, y0 is 1. So we have x0 equal to 0, y0 equal to 1. Now x1 is equal to x0 plus h, which is 0 plus 0.1, which is 0.1. So what will be y1 equal to? Y1 is gotten by replacing n with 0 in this approximation. So y1 will be approximately equal to y0 plus 2h times dy by dx at 0. So we have, what is y0? Y0 is 1 plus 2 times what is h, 0.1 times what is dy by dx at 0? It is x0 minus y0. So what is x0? x0 is 0 minus what is y0? y0 is 1. So at the end of the day, we have here 0.2 times negative 1 is negative 0.2. So this is 1 minus 0.2, which gives us 0.8. Option C, 0.8. A particle oscillates through a distance of 4 and 5 meters on either side of its equilibrium position with a period of 4 seconds. What is the maximum speed in meters per second? Okay, so kind of you are just oscillating, right? So if you're oscillating through a distance of 4 over 5 on either side of the equilibrium position, it therefore means that this 4 over 5 is the amplitude, because you are oscillating between 4 over 5 on either side of the equilibrium position. Alright, so 4 over 5 is your amplitude. Those of you who are doing physics, think about simple harmonic motion, a pendulum bob swinging. If you are swinging between 4 over 5 on the right and 4 over 5 on the left, it means that 4 over 5 is the maximum displacement you can ever attain. Okay, so 4 over 5 is your maximum displacement, which automatically becomes your amplitude. Now, what is the maximum speed? V is equal to omega r is the maximum speed. Okay, so all we need to do is, we have r already, is 4 over 5. Now we need to find omega. Omega is 2 pi on the period. So we have that the maximum speed will be equal to omega, which is 2 pi over the period, which was 4 seconds, times the amplitude, which is 4 divided by 5, okay, meters per second. So at the end of the day, we have that these 4 cancels and we have 2 pi divided by 5 meters per second. So the answer is B, 2 over 5 pi. Wait, is that B or C? Yes, B is B. 46. If there's any question, the comment section is very open. Where is 46? If the moment of inertia of a square lamina of side A and mass m about an axis passing through its center and in its plane is I, then its moment of inertia about an axis through the midpoint of one of the edge and perpendicular to the plane of the lamina is, wow, this is interesting. Square lamina side A. So let's just draw. Let me take the equation to the next page. So first of all, we have to indicate the axis in question. So we have a square lamina, right? Whether it's a rectangle or it's a square, we have a square lamina. Now we have been told that the moments of inertia if the moments of inertia of the square lamina of side A and mass m about an axis through its center and in its plane is I, then its moment of inertia about an axis through the midpoint of one edge and perpendicular to the plane of the lamina is. So first of all, we start by indicating the main axis of the lamina. So the main axis of the lamina is passing through the center and in its plane. So the main axis of the lamina is passing through the center and in its plane. So if this is the center of the lamina, for example, then the real axis is passing through the center. So it's kind of like this, because it's supposed to be in its plane. So the moment of inertia about this given axis here is I. Alright. Now according to the equation, we need to find the moment of inertia of the lamina about an axis that is passing through the midpoint of one of the edge and perpendicular to the plane of the lamina. So one of the edges, and you have to be perpendicular, it means that the axis is kind of like this, okay, where this is actually the midpoint of one of the edge. So the axis that we need to find the moment of inertia about is this axis here, because this axis is perpendicular to the plane of the lamina and it has to pass through one of the edge, the midpoint of one of the edge. So you realize that this axis and this axis are both parallel because the two axes are perpendicular to the lamina itself, so they should be parallel to each other. So we can use the parallel axis theorem, and it says that the moment of inertia about the required axis is just equal to the moment of inertia about the axis passing through the center plus the mass of the lamina times the square of the distance that is separating the two axes together. So this is just I, because I was the moment of inertia about an axis passing through the center, plus the mass of the lamina, was it m? Yes, it was m. Now what is the distance separating the two axes together? Since this is the midpoint, okay, this point here is also the midpoint of midpoint of one of the edge of the lamina. All right, it therefore means that the distance separating the two of them is just the width or the side of the lamina divided by 2. That's the distance separating both. So this distance here is just the side of the lamina divided by 2, and the side of the lamina was a, then we have to divide it by 2. Okay, so I don't know why this thing. Let me just try to group it. I'll remove these ones from here. Okay, so like I was saying, if we work it out, we are going to have I plus ma squared divided by 4. So I plus ma squared on 4, so option C is correct. Option C. Alright, question 47. If you are facing difficulties in this topic, this channel is for you. There are around 12 videos explaining concepts on this topic. If the force F acts through the point with this position vector, the magnitude of its moment about O is, so moment is R cross F. So the moment is equal to R cross F about the origin. So basically, let's just do the R cross F and see what we have. So to get a cross product of two vectors, we use the application of determinant. So we have I, J, K. We begin with R first. 2, 3, 4. 2, 3, 4. Then we go to F. 5, negative 2, 3. 5, negative 2, 3. Now so basically those are the unit vectors I, J and K. So when we keep I, we are going to have a 2 by 2 matrix. When we keep J, we also have a 2 by 2 matrix. We keep K, we also have a 2 by 2 matrix. Now when I cover this and this, we are going to be left with 3, 4, negative 2, 3. 3, 4, negative 2, 3. When we are going to J, there's a negative sign. If I cover vertical and horizontal, I'll be left with 2, 4, 5, 3. 2, 4, 5, 3. Now once I cover horizontal and vertical, I'll be left with 2, 3, 5, negative 2. 2, 3, 5, negative 2. Okay, now here I have 3 times 3, 9. 9 minus negative 8 is 17, so 17i. Here I have 2 times 3, 6. 6 minus 20 is negative 14, but there's a negative sign here, so we have plus 14j. Now I have negative 4 minus 15 is negative 19, minus 19k Newton meter. So that is a moment. But the equation is not asking us for the moment, it's asking us for the magnitude of the moment. So the magnitude of the moment is a square root of 17 squared plus 14 squared plus negative 19 squared Newton meter. Okay, so I think we need to use a calculator here. 17 squared plus 19 squared plus 14 squared equal to 846. Now what is 846? What is the square root of 846? 29. Let me just copy some decimal places. Newton meter. So here is it. Okay, so let's go and check the responses. 29.1. So which one is the best approximation? I think it's 29.1 when we round up. Okay, so 29.1 is the best approximation. So option A for 47. 48. There's one question I want you guys to answer. Let me see. 48. Boom. Let me just answer this one. A particle is moving around a polar curve disk with a constant angular velocity omega. The transverse component of its velocity when theta is pi ln 6 is transverse component of the velocity. The radial component is I think is arrow dot, and transverse component I think is arrow theta dot, if I'm not mistaken. So let me just check from a textbook I have here. Transverse component of the velocity. Okay, I was correct. Arrow theta dot. So arrow theta dot. Arrow theta dot. So this is just theta dot is omega. So omega times arrow. Alright. So we have omega. What is arrow? Arrow is a sine theta. So omega a sine theta. So now I need to replace theta with pylon. Pylon what? Pylon 6. Sine pylon 6 is sine 30. And sine 30 is half. So we have a omega divided by 2. Or omega e divided by 2. So option A is correct. Alright, question 49.